It is finally summertime. When days are filled with beach trips, barbecues, and sunsets, life is good. That is, until you feel that all too familiar sting of a mosquito. These tiny creatures are the uninvited guests at every summer gathering. But what if I told you we're in the midst of a battle, a worldwide campaign aiming for complete sterilization of these pesky pests? Scientists worldwide aren't thinking small scale. They're not recommending we stock up on bug sprays or citronella candles. Rather, they are considering genetic modification, advanced sterilization techniques, and even biological weapons in the form of fungi. But what would a world without mosquitoes look like? Are they really just buzzing nuisances, or do they serve a purpose in our environment? Are we ready to say goodbye to the sound of buzzing that has been the soundtrack of our summer nights since the dawn of time? In this video, we're going to expand on the pros, cons, and ethical dilemmas that would stem from this. We're going to explore the science behind the radical strategies to eliminate these annoying insects once and for all, and what the impact might be on our world. In our quest to eliminate mosquitoes, we could employ cutting-edge scientific techniques. One method under exploration involves genetic modification. Through a process known as a gene drive, scientists are capable of spreading a selected trait throughout a population rapidly. There is currently a modification causing female mosquitoes to become infertile that has been developed. The idea here is that by releasing these genetically modified mosquitoes into the wild, a rapid population decline could occur. This method is currently under trial by Oxitec, a British biotech company. Another strategy is the sterile insect technique. This process involves irradiating male mosquitoes, thus rendering them sterile. Once released into the wild, these sterile males mate with wild females, but no offspring are produced. Over time, this leads to a reduction in the overall population. The International Atomic Energy Agency has successfully utilized this method to control various insect pests. In addition to these high-tech strategies, we could also consider more traditional methods of biological control. This involves using natural predators to reduce mosquito populations. Introducing mosquito-eating fish into bodies of water, for example, can decrease the number of their larvae effectively. An alternative method being implemented by the World Mosquito Program in several countries involves a naturally occurring bacterium called Wolbachia. This bacterium, when present in males but absent in females, ensures any resulting eggs from mating don't hatch, effectively reducing the population. Despite these potential solutions, it's important to note that the idea of completely eradicating all mosquitoes raises ethical, ecological, and practical questions. The eradication of an entire species has irreversible effects. Although current evidence suggests other organisms would step in to fill the ecological void left by mosquitoes, there's no guarantee of what those effects might be. While the thought of completely obliterating them is appealing to anyone who has ever been bitten, it's necessary to dig a bit deeper and evaluate the potential consequences. For instance, what would the global impacts be if we did successfully win this battle? Mosquitoes have been on Earth for over 100 million years, and their removal might send shockwaves through ecosystems. They are, like it or not, part of a complex network of interactions between species. For example, they serve as a food source for various animals, including birds, bats, and spiders. The larvae are also aquatic, providing sustenance for fish and other aquatic creatures. Other insects could become more numerous and take over the role of primary food source for insectivores. However, we cannot predict with certainty how smooth or disruptive this transition would be. Beyond their role as prey, they also act as pollinators. Adult ones feed on nectar and, in doing so, transfer pollen between plants, aiding in their reproduction. Although they're far from the most efficient pollinators, some plants do rely on them. The Arctic tundra is one such place, where mosquitoes play a crucial role in pollinating its flora. Another important aspect to consider is the potential for resistance. Just as bacteria can become resistant to antibiotics, mosquitoes could potentially develop resistance to the methods we employ to wipe them out. What happens then? Are we back at square one, or worse, would we be dealing with a super breed? It's also essential to remember that not all of them are villains. Out of around 3,500 species, only a few hundred bite humans and transmit diseases. The rest are harmless and play their part in the ecosystem without bothering us. This battle is not about annihilating all mosquitoes indiscriminately. Instead, it should focus on those few species that pose a threat to human health. This is the core idea behind targeted approaches like genetic modification and the Wolbachia method, which aim to reduce or eliminate populations of specific mosquito species. Now, let's take a step back and think about the human aspect of this. What would it mean for us, especially those in mosquito-borne disease-prone areas, if we were successful in significantly reducing their populations? Malaria, Zika, dengue, and yellow fever are just a few of the deadly diseases that they carry. According to the World Health Organization, malaria alone affected 229 million people and caused 409,000 deaths in 2019, predominantly in sub-Saharan Africa. If we were to eliminate the offending mosquito species, we could potentially save hundreds of thousands of lives each year. For many people in tropical and subtropical climates, they are not just an occasional summer annoyance, but a year-round, life-threatening danger. Succeeding at this conquest could change the lives of billions of people, allowing children to play outdoors without fear of lethal disease, and communities to thrive without the economic burden of mosquito-borne illnesses. There is also the psychological aspect to consider. The constant threat of disease, the inability to enjoy outdoor activities, and the disruptive noise and itching are all sources of stress and discomfort associated with mosquitoes' reduced populations could mean a significant improvement in the quality of life for many people around the globe. However, it's not all rosy. A global battle could also have significant socio-economic implications. For instance, the pesticide industry, which is worth billions of dollars, would undoubtedly be affected. Jobs related to control, from manufacturing repellents to net weaving, could be lost. There is also the question of accessibility and inequality. Cutting-edge solutions like gene editing or advanced sterilization techniques are likely to be expensive initially. Would only rich countries be able to afford mosquito-free environments, widening the global inequality gap? While it's easy to dream of a mosquito-free world, particularly when you're nursing an itchy bite, the reality is that these tiny creatures are woven into the fabric of our ecosystems in ways we're still discovering. The sheer scale and potential ramifications of their eradication makes this a challenge of epic proportions. But one thing's for sure, as long as mosquitoes continue to pose a threat to human health, we'll keep seeking ways to combat them. Whether that's through genetic engineering, the introduction of natural predators, or by simply keeping them at bay with repellents and nets, the fight continues. So, as always, stay curious, keep exploring, and let's dive into the mysteries of our world together.